Hello, hello, hello. Not even sure if this works or not. Anyway, some trouble with the connection today. I don't know why. But it should be working now. At least I hope so. This I hope so. Okay, let's switch this. There you go. There you go. So first couple of things. You're gonna see a delay on my voice on the camera, and that's live because the setup is what it is. I obviously need my Mac to work because obviously we're gonna be doing some live coding on SwiftUI and stuff like that, so you need a Mac machine. But streaming and using Xcode with this MacBook Pro, it's kind of crazy if you ask me. So instead I have set up the gaming PC, and that means that my mic is connected there, but because I don't have a webcam, I'm using QuickTime. It's a fancy trick that I'm surprised it even works. But yeah, there is a delay, so that's nothing we can do. I'm also not sure I'm gonna have it on all the time, but for now I'm gonna keep it there in the corner, hidden here, so nobody looks that much. Nice. Oh, where did it go? Float on top. Okay, there you go. So for now, that's the plan. We'll see how it goes. So what are we gonna be doing today? Today it's special day because we're gonna be doing some SwiftUI coding. But not only that, we're gonna be showcasing some of the functionality of the Swift Composable architecture from 0.3. If you don't know who they are, well, these guys have been making videos about functional programming mainly in Swift for a while now. I think more than a year, maybe a year. And the point of this stream is a little bit to showcase what the library that they are going to be releasing hopefully in the next few days, hopefully weeks, 2 weeks they say. So that's what we're going to be doing. For that, I'm going to be coding a small macOS application from an idea that I've been trying to do for a while. So I had some part of it already done, and the plan is to port it, kind of like created it for using this new architecture. So that's the plan at least. So I want to show you a little bit of SwiftUI on the Mac, which I think it's useful. It's useful to have under control, basically because it's really easy and make it really easy to make your own tools, and like especially for developers, I think that's amazing. But also because it demystifies a little bit the fact that coding for the Mac is hard, and you still need, people may think that that's not true, but I still think that you need the knowledge of AppKit and to make a fully nice application for macOS. But for your own tools and small applications, SwiftUI gets you so much farther than before without knowing anything. So that's the plan. So let's get started. If somebody has any questions, of course, you can just drop them on the chat. I'm gonna try to answer what I can and what I know. Maybe we get stuck in 2 minutes and we switch to play PUBG, I guess. But if I know the answer and I can help you, feel free to drop. So let's get started, because to be honest, it's been a hectic day and I don't even remember what I wanted. But the plan is to start, yeah, with a sketch of the UI base, which I already made sure that it at least was compiling and Xcode was behaving. So that's the beginning. So what we have here is just a sketch of the UI that I want. I want a picker on top, and then here in the middle, we're just gonna have a list of the applications that I'm gonna be telling you now what's doing. And then we're gonna have a button probably attached to the bottom of the screen that it's gonna help us execute what we want. So the application that I want to do, it's a port of I remember correctly, of 6. It's 6 o'clock. So that's a smaller script that I wrote a while ago, that basically when it's 6, time to go home, it's time to stop working. So I just ran this command on terminal, and everything, it's dead. Kills all the applications that I've been using for work. So Xcode, Slack, all that stuff, boom, close, dead. So I want to make basically small UI on top of this. So that's the plan. For that, the complete idea of the application is that you can create different scenes and you can save the apps on them that you want to group like for work. These are all the applications I use for work. So then I select that as scene and I kill it and everything. But you can also make different scenes, which is something I don't have on that. So that's the main idea. But for now, for today, for a start, we're just gonna focus on showing the applications and them, and that's pretty much it. But I want to do it step by step. So that's what this button is doing. That's why it's called 6, because when it's 6 o'clock, everything is gonna die. And that's the list that I'm talking about. Is gonna be a list of apps on the scene. So what we're gonna see, and then the picker is gonna be a picker of scenes. And then, but of course, we need a way to create a new scene and all that stuff. Again, that's gonna come later. Let's start slowly but surely. So first of all, let's just try to have some structure around the UI. Let's assume this is the picker, but the picker should be attached at the top of the screen. So for that, you can just put a spacer between these blocks of code and then touch in there. And yeah, probably I want a divider here, have like a line, that, and there we go. Yeah, it's not divided, it's so there we go. It's a nice way to start the X with SwiftUI issues, because you need to have like a master to. Isn't it divider? It's divider. Why it doesn't work? Why it didn't work? Now it works. Fair enough. Probably some type. Okay, so now we have this divider in there. We don't need it in practice, but just so it's not that ugly, let's just put some padding. But we're gonna change this view later. Let's just put a line, and we should do the same for the bottom, maybe? Well, no, that's... I know. I misspell half of the code I write, but it still works sometimes. Okay, let's do... So here we need the for each, and here we will need the apps. But for now, pretend have them. And here we're gonna put each row of the application. So for that, we can make let's say that we have some model that represents the app name. We'll probably need more information than this because I think we need like the bundle identifiers to kill them and all that stuff. But let's pretend that's everything. So, and then we can keep. Otherwise, it's gonna complain that they need. Let's just do. So the view should work, but of course now we need to pass information to the preview, so we can make. Maybe. So we have to that should work. Little bit text. Try again. Sometimes you need to keep trying until you convince him. Oh yeah, this. When you're shipping production code, I don't recommend you do this, but one thing I do is I access the previews directly from here, so I don't have to keep these two pieces of code in sync. Makes it really easy to start developing fully on the. Later, of course, when you want to make the application, you need to start of the. But for now, that. Okay. And there you go. Cool. Yeah. Divider in there, and now that we have the list, probably should move the base. So the list. But I'm pretty sure if we don't do this, it's still. That's really odd. So at least we have two applications. And then the idea is that when you kill them, we need to go through all of them and kill all. Like use, I think we need to use the NS workspace to terminate the application. And let me check what I did for that, because that's something I've been already playing with the NS Workspace API, which is a macOS API that lets you access pretty much like the computer. You can actually get the windows, the application opens, you can do a lot of. So I've been working on another application that let me size the windows in a specific, and I've been using that. So let me get that piece of code so I can actually remember. Workspace. Okay, yeah, so we'll need the running applications and stuff, and I need to figure out what's the API to kill them, but that should at least a good way of doing it. Yeah, there is some kill method in there to do it, but I think we need basically the process ID or the bundle identifier. So that's the basic. Maybe it's time. Now I know it's probably too early. Oh, before we continue, let me put some padding on the. And just to show it, because that's something that it's gonna be a mistake that new people with UI does a lot. Like you can put a padding here on the button, and I think that works, but it doesn't because the button is still small. So what I want is to put, basically I want the width of the button itself to be 80. And that's not what this code is doing, but if you come from UIKit or another UI library, that's probably what you think. But the system on SwiftUI works differently, so that's not what it's happening. Okay? So to fix this and to do exactly what we want, what you want is the content of the button. Like a button is just a wrapper on some content that basically adds the ability to be pressed. So what you actually want is the content of the button. And now we're gonna have padding on the text, and you see that the text, it's bigger now, but of course, first of all, we usually want the text to be bigger horizontally. But also like the gray area, which is the UI that the button adds, it's not correct. That's because we're breaking it with this thing here. Like ideally, if we just say, for example, we see that it's bigger, but what we need to do is say horizontal, have some input. There you go. And that's what we want. So now, like by default, like the text here is gonna have some padding horizontally, that it's defined by the operative system. We don't have to. It will change depending on each probably operative system version or something like it. If we move this code to iOS, for example, like the different to update to devices and stuff. But apart from that, I'm telling it like the width of the text, please at least make it 8. Otherwise it doesn't, it looks too small. And even if this doesn't have to be like super nice or anything, well, maybe with the padding it's enough. Let's keep it with it. But what I'm gonna do is then add another padding at the button itself, so the button, there you go, I prefer. So we have this area, but like if you see the blue area, that's the blue area of the padding area, like, but you cannot click outside. That's why you need to put padding here in. It just how SwiftUI works. It makes sense when you understand it at the beginning. So, because we need to handle the killing of the application, of applications and all, what I'm gonna do is already set up the system with the Composable architecture. So that's what I'm not gonna do a full roundup about what the Composable architecture is, because honestly, like nobody can do it better than these guys. There is a lot of videos. They even are writing a book, so I'm pretty sure like that's gonna be out soon too. So I'm not gonna do a better. I'm not explaining it in a better way than Brandon. But I'm gonna try to give you an idea of what's going on, so you understand at least what we're doing today. Okay, but I definitely recommend you to go to Point Free series and subscribe and watch the videos. And like when the book is out, if you're really interested in this kind of architecture, which I think is really nice for the type of things that we do every day, you can definitely learn more. So, by the way, this is a private repo. It's still not out, as I said before, so don't even try to go there because it's private. They are adding more people, just feedback and stuff, and there is like a very nice community, like providing feedback and alternative and make it more economic and stuff like that. And the API it's changing a little bit every day because they are polishing it. So maybe I download now the repo and I don't even know what. But we're gonna be trying. So long story short, what's the Composable architecture? If you have been working on web, for example, you know that they have like a React, which for us will be like SwiftUI, but they also like made things like Redux and many other. Like there are tons of it. And on iOS, in the recent years, some similar architectures like the reactive feedback has started. But I think, in my opinion, none of them have convinced me ever, really. But like the Composable architecture is probably the closest one that I've. There are still things that because they are moving, it's hard to have a strong opinion on it. But probably like up until the most recent changes they did, I was super hyped about it, because it's like every question I had, any problem I had with the architecture, design and stuff like that, they had an answer for it, and it's an answer that it's elegant and it matches really well with the way I think. So that's why I'm so hyped with this, and that's why I want to probably share it as much as I can with everybody in the community. So this is not a niche thing. It actually makes new applications way easier to make. So the idea of a Redux style architecture, or I don't know if they mention it here, it's what it's commonly called a unidirectional architecture. But to be honest, that doesn't explain much unless you have some graphs and stuff like that. But probably the most described, like the thing that describes it the most is the state management. Basically, you have a pure state, a struct. This is not you're not using class, you're not using OOP concepts or anything like that. You have just a struct, a data structure that has the state of your application. And when you want to change something on that state, and I mean anything, the user selected something, we're receiving something from the API, anything that happens, it's reflected on this state. And to change this state, you don't just spread code everywhere on a callback from a button. Like for example, now in SwiftUI, if I wanted to do something here, I will be like, I don't know, or going into the apps and selecting something and doing stuff. You don't spread all this code across your UI code. And yes, usually you don't do that. Usually you make a view model and that stuff. Even in SwiftUI, it's like probably the pattern that most people is using, SwiftUI. But I always thought that maybe we could find something else. So the idea is that you don't spread the mutations of the state across your application because they are harder to track and harder to test. And that's where a lot of people start making layers and architectures and stuff from that. So the way to solve this here is that any mutation on the state goes through what is called a reducer, which is just a function that given the action the user has done, given the current state, like you have these two pieces of information, and then you do the mutation on your state and you return. So that's pretty much what it is. It's just a pure function that does the mutations. And just with that concept in mind, like of course the library has a lot of niceties around that, but that's pretty much the core of it. Okay, like it's, you don't spread your state across everywhere and you don't spread your mutations everywhere. You just have it in a reducer with the state clearly defined in an enum. So, and that helps a lot, especially with testing. It's really nice. The testing they have built for this it's amazing, really. Like it makes you be happy when it's not something that I can. The important thing about this, and that's the second line here, it's side effects. We're saying that the reducer is a pure function. So you cannot change the world. You cannot make API request. You cannot print to the console. You cannot read from a global variable. Like that's forbidden. Nobody's gonna forbid you because the language Swift doesn't have this capability yet. Hopefully, there is a lot of conversations about adding a pure annotation and stuff like that to the language. But as of right now, nobody's gonna. It's just that you should. PRs and tests will have to try to catch. But that's not the limitation of the library. That just the language is not there yet. And so how you do side effects? So we're gonna see one here because we need to kill the app, and that's a side effect. And you do that with an effect object. So your reducer will return effects, and then the architecture is gonna handle the execution of them. All of this, if you come from web or something like that, you already know it. There's nothing new here, okay? What I really like about it, and I haven't seen on any other architecture like this, is the composition aspect. It's really, really powerful. You can break your application. Like the first thing you think about this is like, wait, are we gonna put the state on one big struct? That's insane. The nice thing is that with this composition aspect, you can have every feature on your application, down to every screen on your application, have its own basically composable architecture, its own state, its own reducer, its own effects, everything individually. You can run that as its own application. You can run it on playgrounds if you make that work. So you can have that in a separate package and that stuff. It's full composition and decoupling. It's fully there. And then you pull that back, as they call it, and you make it together in the app state. So you bring all the features together in the app state, and the app state manages it. Really, really nice. So that's an overview. Okay, I know I probably talk a lot, and probably it's hard to understand what I'm saying because they're like, if you don't have the background here, quite hard, but let's dive in and take a look at what all of this means. So before I do that, if you have any questions about this before I jump in, I can try to clarify something, but probably once we look into the code, we can clarify. I'm trying to open this here. But I have Twitch on the other screen, but I'm not sure. Is there a view model on this architecture? No, there is no view model. This architecture doesn't really need view model. Yeah. Recently they added one thing that is the view store, which you could argue is similar, but I don't think it's not the same. You would say you don't code it in the same way as a MVC or MVVM architecture. So yeah, that's different. But let's start with it. So let me just make code compile, because add the package is going to pick up. Because that's what add the package from here. Hopefully get the text my proper git session. Yeah. So you can see that the package comes with the Composable architecture. That's the main. But it also comes with the Composable architecture test helper, I think it's called. I don't know. And you should be adding that into your test. And that's... we're going to have time to showcase that. But these helpers are amazing. Well. So, okay, now we have access to the Composable. So, let me move this app. I want to do a models file. And yes, if you're a purist, you will make a file for it, but use. Okay, so that out of the way. What probably I want to do is my view that I'm gonna be calling. I want to have another view for this. Call it Kill Apps. I like that name. And I'm not using view, the name, because that's one of the things that you really do with it. At least it's the style I'm following, because when you make one module or one component or a screen, I usually do it per screen, you actually want more things than the view. And in my opinion, you can just put them together. So I have this snippet that basically creates all the boilerplate that you need to make this work. So the first thing you need is happened with the name, but that's what I want. Okay, so first of all, we're gonna have the state, then we're gonna have the actions. Then we have the environment, which is going to help us inject dependencies into this screen, which that's basically what. And then you have the reducer. What did I miss? Of course, you need to import. Yeah, and Xcode is happy. It seems that it's happy with that. So should this compile already? Good question. Why not? I made a typo. Okay. This will never be executed. Yes, I know. So the components that you test you test basically your application. It's like if you're working on a screen, you test your screen like fully. Like this is the system that I found that it gives you more tests with so little code and so nice to read code that I think it's hard to really evaluate it until you have spent a lot of time writing tests for a lot of things MVC. I'm gonna try to show you. Please resume this. Reviews like kill X. Xcode is happy, I am happy. Let's move this. And this content view is like one side. But for now, let's start with a new one. So basically what we're making here is the kill apps screen, which is probably the main screen of my application, but that's the concept I want you to understand. We're making this screen, and this screen has a UI, it has the logic on the reducer, it has the state, it has the actions, all of this is on this file. So once you come to read this code, you know where it is, and you know that it's all the time the same. Nice of every architecture, that new, but it's really nice, personally. So what you need for this to work is you don't put the applications here. So what we need is actually a store, and we want a store, and the store it's a generic, of course, and it's a store with this state, it's a store with this action. So that's, and now to the store, basically it's gonna have access to the, and the store is to what you send. So to access that, right now with the current most recent version, unless they have changed it, you use this special view on SwiftUI, and this is just to make SwiftUI really happy with the diffing algorithm and stuff like that, because on previous versions of this, you will never see any problem unless your app was huge and had huge amount of data. But in like performance testing, like they saw that, yeah, you could actually get it. So the solution is you can think of this probably like it's performance. Really, you don't have to worry about it for now. And what we get is a view store, which is what I was talking about yesterday. Somebody mentioned this has view models. It doesn't have view models. It has view stores, which by default you don't have to do anything to get them. Like they are basically just a version of the store, but they give you access to your data to the state. So you don't have to do anything. But if you want to go the extra mile, I'm pretty sure you can actually customize each view store to be tailored to the view. So you can map the state that the reducer, and basically you can see like your business logic state to your view state if you want to map that. I found that I haven't used that yet, but we'll see. Okay, so first we need the apps again. So let's make an array of applications. Let's just start. So now this means, yeah, I've said that it's model, which is something that you do all the time. That should be, now I can access the view store apps. So as you can see, I have access to the state. And that should be fine because that's the same. So this should be. So now in theory, we should have this, the same state that we had now, but now we have it prepared to start growing in a testable and composable. So to create a store, you need to provide with the three different things that, oops, you need to provide it with the three different things that define the store. One is the initial state, which in this case, I think grab from here. So we have the three applications. That's my initial state. The reducer is basically where the business logic is. This guy here. And the environment, here is where we need to create a form. But for now, we're just gonna there. So right now, if I try again, it should work in theory. And like you need to insist a little bit because Xcode sometimes doesn't, you know, it doesn't like it. It will work all the time, but where's the fun on that, you know? So okay, so now we're there. So now, first of all, let's try. Okay, how do we load the applications from the system? That's the first thing we do. To do that, you need to think. You probably will just do it on the view model, on the initializer, or on your view control, stuff like that. You need to think that the only thing you have here is, and the only other place where you have something to mutate that state is your reducer. So you could think, okay, I can do it on the initializer of the reducer. Not quite. You need to think of the reducer as just a pure function. You can see it's a closure that where I receive the state, I receive an action and environment, and that's it. There is no methods, there is no object-oriented things here, it's just a function. So what we can do to load data, and that's something that I haven't really done yet, but let's gonna give it. So we could create an action that could be here probably. And now that's another nice thing, that because everything that can happen to your state is on actions, you can just switch to exhaustively check that everything that happened on your app is properly implemented. You know, like you cannot forget, oh, I didn't handle that method, or oh, I didn't subclass that property of a view control or something like that. That's not going to happen because the compiler checks it. So we have this on appear, and for now, let's do what I said we shouldn't do, which is print something to the console, and we shouldn't do that because that's touching the vault. You're not supposed to touch the vault. The vault is injected to you through the environment. You're not supposed to touch the vault. Okay, so let's do that just for now. Test it. And of course, we should inject our callback here. And the thing is that I'm not sure if on appear is going to be called multiple times, but for now. So now, on appear, what you do? Do you go to the store, to the applications, and you load them through the workspace or something? Well, no, you don't do that. You don't mutate your state in this way. Pretty much, that's what I said. Like the only way to mutate it, it's through sending an action and letting the reducer. And you cannot even do that. I mean, the compiler error is really bad, but this is not working because you cannot do this. So yes, the architecture in this case, it's helping you not make it. So what do? I send an action, and that action is going to be on appear. Okay, so now this part is going to compile. There you go, and there you go. So we got the fallback, which is cool. So what do we need to do now? Did I lose the stream? It's one concept that it's called an effect, and kind of like You can think of it like kind of like a publisher or a stream or feature, like all these reactive concepts. It's similar to that. You can think of it. But it's kind of abstracted away from the specific implement. I think it's using combine, but we don't really, like, it does more things than that. That's why it has its own. So it's a struct again because we don't need an object that we keep around and everything. We just need a function that gives us this effect, and the architecture is gonna take care of execute. What we can do, which is a nice pattern, it's you can make a static let for live, and that's what's gonna make is the live version of the workspace environment. And here you create